So let's take a look at the journal HardwareX, or how it exists, at least online, and just some advice on maybe how to get started or things to take note of. Right, so you just type in Google HardwareX and you find it. So what is HardwareX? Well, HardwareX is a peer-reviewed journal of open source scientific hardware is the real idea. There is some wiggle room on the scientific hardware part. It can also be like appropriate technology, like things like sustainability or things to help developing countries, things along those lines. So the real key is just open source hardware. Anyways, right, it's these days journals are just all digital online. Take a look around and you can see some of their stats. You know, it's an open access journal, so that means that anyone can access these articles. Right, so if I go to latest issue, I can see the current articles, and this is nice because if you're writing a paper for this journal, you can always just look and see what ones did they accept and what did they end up looking like, just so you can get an idea of what standard you need to hold yourself to. So we can see all the open access stuff, but the flip side of that open access is instead of me paying to view the article, now the authors are paying for other people to view the article. So it's kind of flipping the cost model. Yeah, so some information about the journal, some of their most popular articles, blah, 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 blah. That stuff's all there. But what you really care about is this right here, this guide for authors. Right? This guide for authors is going to tell you all the kind of information, rules, and styles that you need to follow for a proper submission. And once again, this stuff is all here, and it's all good to take a look at. Things like licenses, which is a big deal for open source hardware, design files, things along those lines. But really, if we just do a little Control F here, type in template, right? The template is the big thing to pay attention to. Right? That's usually where you want to work off of. Pull your template down first. So I'm going to click that link for template, and I've got a Zenodo repository with docx, ODT, a tex file, and PDF. So, right, whatever you decide you want to make your final submission in, that's completely fine. Here we can see the PDF. Right, this is just a boilerplate paper template, and so I put in my article title, the authors, affiliations, Twitter handles, your abstract. This is the thing that HardwareX has. It's this specification table. So it kind of pairs well with the abstract in that it's telling you what are some of the key aspects of this hardware. What subject can it be used for? Is it used for chemistry? Is it used for biology? A close commercial alternative, that's always a nice thing, so I can compare, especially for cost savings. So I say, oh, this doodad, I can pay $100,000 for it if I buy it from some company, but I can 3D print it for a tenth of that cost. Right, so having that commercial analog is nice. The license, the cost, a spot to find all those files, and then if you have a certification, you can put information about there. And then finally, we get into the actual the meat of the paper, right? The hardware in context. So that's providing comparisons, the drive for why you wanted to do this, or what's the use of that design, where it fits in other open source ecosystems, things along those lines. And then we get into the description of it. We need to have good called out information on our design files. So what files do other people need if they're going to replicate this? What are the files? What are they used for? Things along those lines. So there's a table for that. And then, of course, the bill of materials, parts that people are going to need to order. Another big thing, right, when you're publishing open source hardware is you need to be able to replicate it, or you need to convey for people how to replicate it. And so that's where the build instructions come in. And of course, operation instructions once they've got it put together, how to operate it. And then, of course, we've got validation and characterization. So you need to show that your design is actually doing what it intended to do, and also need to characterize how well it is doing that, right? Because some of those numbers on how well or how accurately your device can work, um, that's going to be important information for researchers if they're making these tools for their own research. And that's really it. Of course, there's other things that need to be filled out in your references. But yeah, I would say that should be enough to really get you started, right? The big thing is to pull in this template, and then you can always look at other papers or the expanded guide for more information.